To start off with, we would like to give you all a little bit of context into the motivations behind Kubectl Apply and some of the decisions that went into its implementation. Kubernetes is a declarative system, but that declarative system is primarily managed through imperative APIs like create, update, delete, and patch. And lots of users wanted a more declarative way to manage their clusters by defining a local state and running something to push that state into a cluster. So Kubectl Apply was written to do just that. You will have a directory of resource configuration, and when you run Kubectl Apply, your declarative configuration will be transformed into imperative requests that will get sent to the cluster to enact your desired state.
Wait, Jenny. Declarative management of Kubernetes resources, is such a thing even possible?
Yes, it is. You might just think that we could naively replace the state in the cluster with the user's local state when apply is run, but that doesn't actually work because the control plane is going to add some state of its own every time you make a request. For example, when you create a service, a cluster IP field is added that allows your cluster IP to be known. And if you just naively replace the state in the cluster with the local state, that field is going to get wiped out, and that's not good. And there are other fields besides this one, and they're set by admission plugins and webhooks and defaulting. So instead of sending a replace request, we're going to do a patch, and that's going to preserve those fields that we don't know about. And the patch is generated from the local state in the system, the last applied state, and also the current live state in the cluster. So how are we going to generate that patch? The first thing we need to do is to perform a diff on the last applied state and the current state in the user's local environment. And where can we get the last applied state from? We made a decision with Kubectl Apply to just add an annotation to every resource that's being applied, which is a copy of the entire resource configuration. So not sure if that was a good decision, but it worked. It works well, so it worked at least well enough at the time. And now that we have the diff, we need to transform it into a patch request because the cluster doesn't accept a diff. And we started out using a merge patch, but we quickly realized that merge patch wasn't expressive enough for the types of operations that Kubectl Apply needed to do to these resources. For example, you can't delete a list item indexed by a key field with the merge patch. So we created a new patch format, strategic merge patch, which you've probably heard of, and it's just like a merge patch, but there are some imperative merge instructions that are put on top of that merge patch that tell the cluster more specifically how to update the object. And as we found more people using Apply, we noticed that there were other cases that weren't covered by our patch format. And we just added more and more of these imperative patch directives, and it got really complicated to make a strategic merge patch. And so tools that wanted to benefit from the Apply workflow would just exec out to Kubectl Apply to get the same behavior. And this is not the best situation because all the tools are going to have different versions of Kubectl Apply, and the behavior is not going to be consistent at all. And the version of Kubectl Apply being run really matters because some of these patch directives are set depending on the version of the client, and some of them are set depending on the version of the server implicitly once it receives the request. So the behavior of Apply is going to depend on both the version of the client and the server, and not even all combinations of these versions are supported. So it's not a good situation.
Yo, dog, I heard you like diffing.
I don't like diffing.
Oh, let's come up with a new solution then. Okay, so what Jenny just finished talking about is challenges when you're trying to take the resource config for one resource and push those changes into the cluster. There's another set of challenges with declarative application management, which is about the authoring of the resource config itself. So the vision is that users can author all their config declaratively, put it in this nice directory. You can write Kubectl Apply on that directory, and it will just magically make the resources appear in the cluster, right? If they need to be created, it will create them. If they need to be updated, it will update them. And if you change those resources, then it just gets pushed. So there are actually a couple challenges with this. The first is around config maps and secrets. So config maps and secrets are oftentimes derived from some other source of truth. The secret is really comes from some key file. The config map may come from some environment file. And so what a user wants to do is change the environment file or the key file and then have that pushed into the cluster. They don't want to necessarily write a script that then regenerates all the resources before doing the declarative steps. Another challenge is when you push a config map or secret change, it's actually consumed by pods. And those pods might consume it as environment variables or as command line arguments. And pushing that config map or secret change doesn't necessarily do anything to those pods. And so you won't see that change reflected, right? And the way users are used to rolling out changes to deployments, for instance, is they push a change to the image or something like this, and then you get a nice rolling update. New pods are started, health checked, and then the rollout progresses, right? Instead of kind of an all-at-one shot. So what do we tell users to do? Well, one recommendation we gave is create a new config map and new secret when you make changes to those files, right? And so now you change your deployments to point to those new config maps and new secrets, right? And then you actually get a rolling update because there is a change to the deployment itself. So this is actually just really easy, not imperative at all. You just write these imperative scripts to regenerate these things. Use the hash suffix flag to make sure you get a unique name each time. Go find everywhere you reference those things, and then make sure you update them and go and apply, right? So it actually does start to look pretty imperative. Another issue has to do with metadata and fields that are set across many resources. And a common desire is to perhaps set an annotation across a collection of resources where all those resources are part of a single release, and you want to annotate them with the release. And you don't want to go update every single resource file. You just want to update one place that says, here's the new annotation. Labels are similar to this, and especially namespaces. Right? If you have a collection of resources that you know what you want to go into the same namespace, like services that refer to pods from deployments, you don't want to have the possibility of introducing this error where you leave the namespace off one but not the other, or you copy and pasted one that had the namespace set to a different thing. Right? This is just a way of introducing error into your system. And so there was the -in flag introduced to Kubectl Apply. And so this allowed you to apply a set of resources to a single namespace, but that data isn't captured declaratively anymore. It exists in some script, some other place, right? And so if you just look at the resource config that may be checked into Git, where are these things actually getting applied? Well, you have to look someplace else. So what did we decide to do? We recognize that there's two parts of this problem. One part of the problem is about taking a single resource, pushing updates into the cluster for that single resource, the complexity surrounding that, the ability for other tools and controllers and other systems to take advantage of that logic, right, on a single resource basis. A second problem was about users actually managing their resource config declaratively, right? And how can they do updates to secrets and do updates to config maps and express this higher level logic that we've already put into kubectl as imperative commands. So we already know that users want high-level access to this sort of stuff, but we haven't provided a nice mechanism from the declarative way.
I was thinking of a third project. Could we use the elder sign in this logo as our new logo?
No, I really like the Kubectl fish that we have today.
I thought it was pronounced CTL fish.
Well, you can pronounce it CTL fish, cuttlefish, or control fish, actually.
Okay, so for the first of those projects, what did we change in server and client relationship? We used to require a client that wanted to use this apply operation to maintain a last applied configuration annotation and to do some client-side diffing and to generate a complicated strategic merge patch request. And in practice, no one was doing that implementation themselves. They would just exec out to Kubectl Apply, and it caused lots of problems that we already talked about. So instead of that, we decided to develop a new API endpoint for Apply that would natively speak the language of Kubernetes resources and understand the specific quirks of each resource type. This way, instead of the client doing lots of work on its side, you can just send your configuration for a single resource directly to the server, and it will understand what you intended to change. And instead of you managing that annotation, the cluster is going to manage a new field called manage fields in metadata that will keep track of the last user to update each field in the object. So by moving all this work and logic into the server, it allows tools besides kubectl and controllers now to take advantage of this workflow and have greater consistency between them, since the behavior only depends on the version of the server. And in moving Apply to the server, we also found some other functionality of Kubectl Apply that was more natural to be done in the server than the client. And one of those is dry run. And dry run was a flag on Kubectl Apply, which told the client to generate the patch request as normal and apply it locally to a copy of the object that it had requested from the server at some point earlier in the process. So this was pretty good. It worked pretty well. People could see what was going to happen when they ran Apply without it actually changing their cluster's configuration. But it wasn't perfect. And the reason is that the server actually changes your request before it gets committed to the storage. It has admission plugins and user-defined webhooks and also defaulting that all change your resource before it gets committed. So when we move dry run to the server as a query parameter on all the modifying endpoints, like create or patch or delete, what we found is that it's more accurate than it was when we did it on the client. And when we combined the apply endpoint with the dry run parameter, it creates a more accurate diffing tool, kubectl diff, and that's going to allow users to see exactly what's going to change on the cluster the next time that they run Apply. And so they won't have any surprises or unexpected changes to their cluster. And the last thing we changed is those implicit patch directives that the server sets on the patches that you send are being replaced by a more declarative structure that is defined for the schema of the resource. And it's useful for things besides Kubectl Apply now, too. It's useful for CRD field pruning and diffing.
OK, so now what did we do on the client side to address the challenges with authoring the config? So we came up with a new declarative file. And this is a meta resource that isn't actually applied itself to the cluster, but describes how to apply resources, right? In the kubeconfig file that describes how to talk to a cluster is another example of something like this. And so what I've shown here is part of a customization.yaml file. And so the first thing we did is we put on generators for the secrets and config maps. And so what you can see here on the slide is the first entry is about how to generate a config map. And so what this directive says is generate a config map with the base name app-config from an environment variable or an environment file with the same name. For each line in that file, go create a new data entry. And so those can be used as environment variables and as flags from the pods. So when you change that M file, it will then generate a new secret with a new name. And it does this by applying a suffix, a unique suffix to the name of the config map it generates. So the deployments and the stateful sets and the different workloads that want to consume this config map can do so referring to that app name, right? The app-config name. And then customize, because it's schema aware and it knows what a reference to a secret looks like and it knows what a reference to a config map looks like. And because it has a visible view into all of the resources that are being customized, it can go then change the references to those, right? And so it can substitute the app-config name with the hash suffix name, right? And so this allows you to get that rolling update behavior that we've kind of been asking users to manually do. The second entry is for a secret. This is very similar to a config map. It looks basically the same but generates secrets. And in this case, it generates a TLS secret from a couple files. The ways you can generate config maps and secrets actually looks really similar to the ways you can do them imperatively with the kubectl create secret or kubectl create config map commands, where those commands allow you to specify literals, specify files, or in files. The declarative commands allow you to do the same thing. Lower down in the customization YAML file, you'll see a resources section. And so what this is about is enumerating the resources that you want to apply. Instead of applying a directory recursively, right, where you just kind of get whatever you get that happens to be in that directory, Customize has a view into all the resources that it's going to work with. And this allows it to go and find which resources refer to these config maps, and then go and update them and transform them before they're actually sent to the cluster. The last piece on the slide is this thing called bases. And bases are about factoring config into multiple modules, right? Whereas before you might have several different directories of resource config, and you pass each one with a -f flag to apply, and that's how you get separating the resource config into different sections. Here you can just have a single target, and that target will refer to other bases. And those other bases are customization YAMLs. Right? And so you can refer to a base which generates a secret or generates a config map or has its own list of resources. And so you can begin to compose these things together declaratively instead of on the command line.
Be careful. I heard that time flows 20 times slower in bases.
Yeah, well, most of that time is spent cloning a Git repo. Some of you actually get that joke, too. The second piece of the authoring piece that we were trying to address was about these kind of meta-level transformations, right? Certain best practices around applying labels, applying annotations, putting things in namespaces. We tell users to do it, but we didn't make it easy for them, right? So how can we make it easy for them declaratively? So you can see that we now have a top-level field called namespace, right? And now, right in the all right.
Should we go to that?
Should we go to that? It's a good excuse. As I was saying, the namespace is now a field you can specify declaratively, right? So someone looking at this YAML config can look at, OK, here's the resources that are being applied. Here's the bases that are being pulled in. And here's the namespace this stuff is going into. If you add a new resource in there, you don't have to worry about, did I update the namespace or did I screw it up? The second pieces are around labels and annotations. Name prefix. So another common pattern actually is for users to have some naming convention around their apps, right? You may want all your dev resources to have the dev-prefix name. Or you may want your prod resources to have the prod-name prefix. Right? And this can make it easier just to look at a resource and say, yes, I know this is a dev one immediately without having to go look at what namespace is it in or what labels are on it, right? And if someone happens to be manually deleting something with kubectl delete and in the wrong namespace, then they don't accidentally delete your prod one because it happens to have the exact same name as your dev one or something like that. So this was kind of a fun new feature we introduced. The others are annotations and labels. The annotations, it's exactly what you'd expect. You specify top-level annotations, and then it will apply it to all the resources. And the labels, similarly, get applied to all the resources, but they also get applied to the selectors and the labels of the pod templates. And so this allows you to define like top-level wiring across all the resources in your project. You do have to be careful with this because it does apply to selectors. And certain resources like deployments don't allow you to change selectors after the deployment is created, right? And changing selectors arbitrarily can have odd side effects.
These transformers are great, but aren't they really just workflow optimizations?
Actually, I think they're Optimus Prime-izations. These jokes are going way better than I thought they were going to go.
I thought it would be crickets every time. It was
we had a whole series of jokes to make fun of how silent everyone was going to be.
All right, so you might think from what we told you that this is a solved problem and there's nothing left to work on. But in 2020, we have a few areas that we still plan to improve. And one of those is pruning. What pruning means is if you apply with a resource in your directory once and then apply again with that resource missing from your directory, and you specified pruning, that the resource should be deleted from the cluster. So we have something like this already, but we still want to extend it to support deleting created config maps and secrets. Another thing we want to do is to support Kubectl Apply blocking on the status of the resource being created. So when you apply a deployment to update the image, the request is going to complete before the image has been fully rolled out to all of the replicas. And this is the intended behavior. You can check the status of the deployment yourself to see if it's been fully rolled out. But some users might want to have a blocking Kubectl Apply request so that they can be sure that their changes have fully propagated. And we don't just want to support this for built-in types like deployments. We really need this to work for CRDs as well. So we'll need some mechanism for CRD authors to define which fields in their status are blocking and what values should be waited for.
Finally, some other interesting things that we're going to be working on are around how we develop the CLI tools themselves. Today, we're kind of in this weird state where Kustomize is in actually a separate repo. The code for Kustomize was built in a Kubernetes SIGs repo. Kubectl is still in the main repo. And the reason we did Kustomize as a separate repo was because we wanted to be able to get user feedback quickly and address it and experiment with, is it possible to actually build something outside of Kubernetes? For a long time, it was like, can we actually split up the mono repo? And this was kind of a chance to see if we could. And it did have some nice things as a result. We were able to get feedback from users who could actually take a build of Kustomize and then make changes and then push a new build within 2 weeks and get more feedback, right? And that worked out nicer than a 3-month release cycle, right? Where it was a lot harder. There were challenges around getting that code back into Kubectl as a result of it being outside the main repo. And we had to do some fun engineering tricks to get around various vendoring cycles. We actually want to move Kubectl outside the main repo. This has been something that we have been trying to do for about 2 years. And it has been a massive task that I think is harder than anyone expected it to be and has burned out a lot of maintainers. And people have moved off of it. But we're very close today, and it's going to move into something called the staging directory. And then we firmly believe, despite other people saying it's impossible, that we will move it into its own Kubectl repo. One of the reasons this is important is that today, Kubectl is built alongside the cluster as part of the same release. right? And so when we test kubectl, we bring up the cluster, the same code in the cluster, and bring up a cluster with the same code as kubectl at the same release, and then get to test them against one another, right? And then we have this other separate version skew testing thing as a separate entity. In reality, when users actually consume kubectl, they typically download it independently of the cluster. Like the cluster's over here and kubectl's locally over here, or it's in a container over there. And so that means your version of kubectl is probably not always matching the version of the cluster, right? And you're either one version behind or one version ahead. And you'll encounter fun things with Go serialization, for instance, where certain fields get dropped when you serialize them and round tripping. And so there's a lot of challenges around supporting version skew between these things. And by moving kubectl out into its own repo, it becomes much more obvious that it's decoupled on a separate release cycle, and therefore we have to make very intentional decisions about how we are going to support multiple Kubernetes releases and how we're going to test and validate that stuff.
Hey, Woody, would you say that in 2020, Apply will boldly go where
Wait, Jenny, that's Star Trek, and it's not a Star Trek meme.
Oh, apply to infinity and beyond?
Yeah, nailed it. All right, so finally, getting to questions. What Ginny and I have done is talked at a very high level about, yeah. It's funny because it's true. We've talked about, at a high level, about where Kubectl Apply came from, many of the challenges users were encountering, kind of how we worked around them in the short term and the guidance we gave to users, and then how we tried to look at those challenges and figure out what can we do to address them. But if you really want to take advantage of this stuff, you'll probably want to take a look at the documentation linked here and begin playing with them hands-on.
When you say questions, do we get to ask them questions, or are they just asking us questions?
So I thought we'd do like a Jeopardy thing where they give us questions in the form of answers, and we give them answers in the form of questions.
Oh, okay. So I'll take Kubernetes trivia for 200, Alex.
The answer is kubectl.
How do you pronounce the Kubernetes CLI?
Wah, wah, wah. All right.
All right, if there's one thing we've learned, it's how to pronounce kubectl, and I just did it wrong. All right, any questions for?
Hi. Aside from the whole customize getting into mainline and the arguments that caused, what lessons did the customize team take from Helm, which already does a lot of what customize does? How can you reassure people that those lessons were already learned, or that someone actually looked at it?
Yeah, great. So the question was, what lessons did the customized team learn from looking at Helm? And I think of the two as complementary. One of the big lessons was that the last mile of customization is hard with templating, right? How can a user, templating is great, like to have an abstraction with a set of knobs, right? But then when someone wants to break through that abstraction, are you able to break through it to the lower level, right? And how easy is that, right? And that what we were looking at is how can we enable that, right? And so that was actually done through this notion of patches, which I didn't get a chance to talk about. But if you look at the way the API machinery looks with controllers, and you look at the original patch logic for Kubectl Apply, one of the mechanics was we generate we're schema aware, and we're able to generate patches and overlay this config onto that config without having a notion of the whole thing, right? So like Jenny was saying, the cluster IP how do we just override this set of fields without blasting the cluster IP, or these sorts of things, right? And so we looked at that and we said, actually, we can provide kind of like arbitrary last mile customization using that exact same mechanic, but instead of applying a patch to the resource in the API server, right, a human patching over a robot, we can actually have a human patch over something written by another human on the client side. So I think that's one of the lessons learned, and I think Vic Iglesias has done some talks on the ways Kustomize and Helm can be used together to complement one another.
Hi, my question is, are you planning to make a secret generator in Kustomize pluggable so that we can support secret generator like sealed secrets? Because we're trying to commit the secret in Git so we can do GitOps.
I'm so glad you asked this question. Yes, we actually are doing some things that are really exciting around just that. We're planning on making every sort of generator pluggable, so it's not just secret generators, it's not just config maps, but to actually allow users to generate arbitrary objects and do arbitrary transformations, right? If you look at the architecture of this, it's just about how do I have high-level generation of a couple objects, and then how can I do some transformation of looking at the total collection. That's in early alpha right now, and I think there's going to be a lot of back and forth on what's the best way of developing that in a way that we're able to allow the broader ecosystem of tools to take advantage of it and allow them to maybe plug themselves into kubectl more directly through possibly building plugins. But yes, there's already actually an alpha ability to both do just secret generation, and then there's the ability to do arbitrary generation of resources as alpha as well.
Thank you.
Hey, so quick question. Now that we have customized, integrated, and we have the kubectl diff, are there any recommended ways to, so we're basically using the YAMLs from upstream, you're not using Helm. And is there any dark art to use the kubectl diff to auto-generate the differences between the upstream? Or how do you recommend staying close to upstream YAMLs using kubectl diff and Kustomize? Is there any recommendation?
So I think the question was how that you're using upstream YAML files,
Yeah.
and that you want to get a diff between your local copy of those upstream YAML files, or the changes between your copy and those upstream ones?
Yeah, keep close to the upstream YAMLs and only have the patches in our repo, if there is any way to automatically generate the patches with kubectl diff.
So you have you've changed you've forked basically a YAML file, is that what you're saying?
Yeah, we're cloning the upstream, but we want to keep close to the upstream with Kustomize.
So one way of doing that is to actually use the patching mechanism I described earlier. It kind of depends on the specifics of your environment and setup. If you are trying to do something very simple like we want to use the upstream, but we want this one arbitrary field changed or this set of arbitrary fields changed, you can actually use a patch to just not actually modify the source. And so you can just look at that patch and you can see these are the things I've changed from upstream without having to do a rebase. So that's one approach. If you are just taking another YAML file from some Git repo and changing it, then maybe git diff is enough for you in that case.
Okay, thanks so much. I think we're out of time, but I think Philip and Jennifer will be around to talk more.
Yeah, grab us outside in the hallway if you have any more questions.
Okay, thanks a lot for coming, and thank you, Jennifer and Philip. And again, don't forget to rate the session on shed.com.